Hello and welcome everyone to our December Infura Developer Community Call. Yeah, we're here with May, EG, Gonzalo, Ankit, and myself, Shay. Each one will introduce as they speak to you all. Just some quick housekeeping around Crowdcast, which we're using today on the call. As you can see on the right-hand side, there's a chat that you guys can continue to have conversations. If you have any questions, please add them to the Ask a Question queue that's on the bottom there. Now, if you add a question into the chat and you put a question mark, it'll prompt a little button that says, hey, would you like to add that to the queue? Hey, little, hey, May, I see your cat. But go ahead and you can say, yeah, sure, add that to the queue, or you can add that directly to the queue. Now, the advantage of that is that we'll be able to see your question more noticeably. And also, if you're interested, you can come up on stage and ask your question, or I can ask it on your behalf. Either way, I'll ask you when it comes up, and then you could say yes or no in the chat. But yeah, please put those there so that we can keep our eyes on that throughout. We'll try and answer questions as they come up, and then we'll also leave time at the end to answer any remaining questions if we can get to all of those. Also, please check out we have a call to action at the bottom there that says join us in our Discord community. This is where we have all of our conversations where we love to continue the conversation around these calls. If you want to, you have any kind of high level questions that we weren't able to get to. If you need support, there's a different support kind of ticket route, but we can guide you in that. So as long as you're in the community, we'll try to triage you accordingly. And then without further ado, I'll hand the mic over to May. I think you're on mute. There you go. Got it.
Yeah. Hi, everyone. Should I share my screen, Shay, or would you want to move through the slides? So hi, I'm May Chan. I'm the lead for all developer tools for product marketing. I'm really excited to present our third Infura Developer Meetup. This has been a great experience. We started off not really knowing how the community will perceive these meetups, but we've been so excited by all of the great response. And this is our last one of the year, but definitely not the last. We're going to start off with EG, our co-founder of Infura. He's going to talk a little bit about what happened in 2021 and some of the exciting things that are coming up in 2022. We also have Ankit Meiti from Polygon. Polygon, if you don't know, has just been going to the moon, in the past couple of months. And he's going to talk about a new gas swap feature that's going to make it very easy for you to buy tokens on the Polygon network. And we have Gonzalo, who's the co-founder of Diligence. And if you don't know, Diligence is one of the top smart contract audit services out there in the blockchain space. He's going to come in and talk about a new product from Diligence called Fuzzing that's going to make it easier for you to make sure that your smart contracts are secure. And last but not least, I'm going to take some questions and send you off into the holidays. But please welcome EG, our co-founder. He's going to talk a little bit about what's been happening at Infura.
But EG, sorry to interrupt, and May, thank you for the intro. One last thing I forgot, because this is new to our calls. I forgot to mention that we are offering up POAP badges or POAP badges that you guys can claim for attending today. We'll send that in a follow-up email where you can, there'll be a link to claim that badge, and that will give you a chance to win a 3-month subscription to Infura. So that's an exciting opportunity there. And we're really excited to have you guys be able to collect these badges going forward. So thank you. EG, you're on.
All right. Hey, everybody. Thanks, Shay. Thanks, May. So yeah, next slide, please. So wanted to introduce myself in case you haven't seen me on one of our previous calls or presentations. My name is EG Galano. I'm the co-founder and head of engineering for Infura. Let's see. All right. Shay, are you the one still driving? Could you go to the, there we go. Yeah. Couple back, the one with the black background. So yeah, just wanted to start with thanking everybody for having a great 2021. It was a pretty surreal year for us, for the ecosystem. There were a lot of different things that happened, starting with at the beginning of the year, we launched our Infura Transactions feature, which was really great to finally see. The three people primarily leading that for us, Patrick, Lucian, and Chris, did an excellent job getting that out and in front of developers. If you missed one of our previous calls going over ITX, it's a transaction relayer that makes it a lot easier and simpler for people to onboard into the Ethereum ecosystem, both as developers and users. It simplifies and abstracts the gas experience. So that was a great way to start the year strong for us. And then very soon after that, we started adding the first networks to Infura that we had ever added, besides the traditional Ethereum networks and Ethereum testnets. So you saw us add Polygon. We have Ankit on the call. We have a great relationship with the Polygon team. We saw it was maybe not around this time last year, but a couple months after, I'd say around end of January, we were seeing that transaction fees were getting extremely painful for users of the Ethereum network. And we wanted to know like what we could do as an infrastructure provider to help with that, which is why we released the ITX feature. But on the other side of it, it was looking at what things could we do to offload traffic onto some other networks that would make it simpler for applications that needed scale immediately to be able to handle the load that was being put upon them. And Polygon was ready and was there waiting. And we saw the latent demand for it, because as soon as we released the Polygon network feature in the spring, hundreds and thousands of developers signed up and just immediately started using the Polygon endpoints that we enabled. That was really interesting to see. It was an interesting scaling challenge for us, because traditionally, whenever we had stood up a new service or feature, it would be a slow kind of ramp up period where we could take a look at how our infrastructure was handling things, and we could adjust accordingly and optimize. And with Polygon, that was definitely not the case. The moment that I would say we opened the floodgates, developers started pouring in saying, we've been wanting this for a long time, started utilizing the Polygon endpoints and coming to us with additional features of other things that they wanted us to be able to support on Polygon. So that was really great to see. Then after that, of course, it was like the summer of layer 2s this year. And just like it was DeFi summer in 2020, this, I think, was layer 2 summer. We quickly added the Optimism and the Arbitrum networks. And similarly to when we added Polygon, there was immediate demand for these things as soon as we added it. I think with DeFi and TVL providing opportunities for people on networks as soon as they're available, we no longer see that slow ramp up period for developer adoption. As soon as the network can help people realize some sort of benefit, whether that's lower transaction fees, improved transaction throughput, or some new functionality that makes their application better, people are going to start using it very quickly. And that's thanks to the EVM compatible kind of mindset that the ecosystem now has. People are no longer proposing like radical alternatives to the EVM. People have started to kind of coalesce around the EVM being the lingua franca for these blockchain networks. And so if your blockchain is EVM compatible, or this blockchain that you're looking at integrating with is EVM compatible, you're not going to see the difficulties in getting that developer mindshare that new projects typically did. And so that was one of the other things that we worked on this year, is a lot of behind the scenes things, things to improve the performance and optimizations and make it a lot easier to add these networks in the future, because we don't think these are going to be the only EVM compatible networks that we're going to support and the ones that developers are going to want. So we've been preparing our infrastructure to be able to scale with the requests and demands of our user base. Next slide, please, Shay. That kind of is a good way to start leading into what's coming in 2022. Next slide, please. So more new networks are coming, starting with Aurora. If you're not familiar with Aurora, it's a layer 2 built on top of the Near protocol. Near is an excellent layer 1. They have a fantastic technical and engineering team over there. Aurora is an EVM compatible layer that was built on top of the Near blockchain. So you can basically interact with the Aurora gateway, which is something that we're going to be supporting in Q1, but something that's already available now that's run by the Aurora group itself. You can send a transaction, like an Ethereum transaction, to this Aurora endpoint, and that Aurora endpoint basically wraps the transaction in a Near transaction and propagates it to the Near blockchain, where it ultimately executes and is stored. So this means that you get the benefits of the Near network with compatibility with the EVM tooling that you're familiar with. So MetaMask supports it, Infura supports it. All of the tools that Diligence has provided to, like open source tooling to be able to test your smart contracts and things, many of those things will still be compatible if you're going to be looking at Aurora. And that's just one of them. We'll have more announcements in the new year, but that's the one that we can talk about for right now. Besides that, more enhanced dashboard functionality. I know we went over our improved stats on one of the previous calls. That's going to be a big focus for us in 2022. Developers want to understand more about how their applications are being interacted with, how they can optimize their applications, what sort of patterns they're seeing that can help them improve their application. And they're asking us for specific features. So they want to see, more insights into transaction visibility, errors, logs coming back from errors that might be coming from the server side. And we're going to be exposing as much of that as possible. If you have any additional feature requests, our community forum is very active. Our team is in there every day looking at things that our users are asking for or asking about. And so if there's something that you're like, oh, this would really help me if I had this functionality inside of our dashboard, please put it in there and let us know. Additionally, we're going to be seriously improving our documentation and education resources. We were at a point where we felt like, this is material that we've covered before. Infura has been around since 2016. There are certain things that we started to kind of take for granted, like by now developers understand how this API method works, or how this the best pattern to use when you're trying to build an application that does X or Y. And what we saw was that not only has that evolved over time as the underlying tooling, whether it's the Ethereum node APIs themselves have improved, or developers have found different ways of utilizing things. A good example is the Flashbots project, and how Flashbots offers an API that makes it safer, might be a good word, safer for people to send transactions to the chain without getting front run. That's not something that really existed a year and a half ago. So that's kind of changed our perspective of, okay, maybe we should revisit all of our education material and our documentation, make sure it's as relevant and valuable to new users entering the ecosystem as possible. So we want Infura and the Infura landing page to be a place that developers can go to and quickly find the answers to the questions that are paining them. What's slowing you down? What's making it difficult for you to just develop and ship whatever it is that you're working on? We want to be a resource for you to answer those questions. Then the big thing that's going to be taking up a lot of our team's energy over the next 6 months, hopefully about 6 months, is the ETH1 and ETH2 merge. That's not a small feat. Definitely on the protocol engineering side, the foundation and research teams, the client development teams have been working on this for years. It's something that's been evolving and iterating on. They just launched the Kitsugi testnet a few days ago. That's a big deal. It's supposed to be a long-lived merge testnet where they're finally testing the merging of these Ethereum 1 and Ethereum 2 clients and how they're interoperating. The next few weeks of that testnet operating will really show the maturity and readiness for the merge. And maybe there's going to be no issues, which is great. And even if there are issues that are found, that's great, because this is where we as the community want to find these issues is on the testnet and not after we actually do the merge. So people that we're working with, we're working very closely with the Ethereum Foundation, the Teku and Besu client development teams within ConsenSys. We're all trying to work towards making sure that we find any issues both on usability, like how will this work for people trying to run their own infrastructure, and just stability for the network overall. And then especially for us as Infura, being an infrastructure provider and operator, how will our infrastructure run leading up to this merge with Ethereum 2 and afterward? Like, what are we going to need to change and let you as our developers and our user base know if there's anything that needs to be required for you leading up to that? And so please subscribe to our community newsletter. We're pretty good at putting in things there that you should care about. We try not to just make it a bunch of things focused on like traditional marketing type things. We really want it to be actionable items that we feel like developers should be aware of and should care about. And so as we lead up to this Ethereum 2 merge, we're going to be putting in more things in there that'll hopefully be useful to you. And then the last thing that I wanted to mention is that we recently open sourced some additional tooling for our IPFS product. There's a IPFS upload tool that makes it easy for people, whether it's switching your IPFS provider or migrating a lot of your traditional content onto Infura's IPFS service for the first time. It makes it a lot easier for you to do that en masse. We've released some other things in the past to also make it easier to switch from another IPFS node that you might have been running to our service. This is something that kind of extends that. And then we're going to be continuing to release open source tooling that helps people that are choosing to run their own infrastructure, whether it's monitoring your own Ethereum or EVM blockchain nodes, running that stuff yourselves. And maybe in the future, well, not maybe, definitely in the future, we're going to be open sourcing some of the pieces that we use internally to run Infura, because we're seeing that blockchains are getting harder and harder to run. They grow indefinitely. No matter how small, we try to optimize the state of the Ethereum blockchain or other blockchains. Blockchains are getting faster, and that data gets stored somewhere. There's no magic to make that disappear. You can use some fancy cryptography and math and computer science to minimize that as much as possible. But transactions always generate some amount of data, and that data is going to continue to grow indefinitely. And so we're always looking at how we can optimize the way that we run our infrastructure. And we're at a point now where we think we're ready to share a lot of this with others. So keep an eye out for that in the new year. So that's where I'll end for now. Shay, do we want to do questions for me right now, or are we going to do it all at the end?
Yeah, let's have some questions. I think we have a couple in here. We do have one from Sankara. Is it Infura API support ETH and Matic chains only, they said? Does that make sense? is it Infura API support ETH and Matic? I guess they're saying, does Infura API support ETH
So we do
and Matic
support
chains only?
the Ethereum chain. We support the Matic Polygon chain. And besides those, we support the Palm network. We support Arbitrum and Optimism as well. If you're familiar with those layer 2 scaling networks, so the optimistic rollups. And then Aurora, which I mentioned, will be coming in Q1.
Awesome. Thank you. Thank you for the question. Also, one more, and then we can come back to at the end, also, EG, to answer any other questions that come through. From Gustavo, is Solana EVM compatible?
I'm not aware of Solana being EVM compatible right now. I think I saw that somebody is working on an EVM compatibility layer for Solana.
Okay. What about Filecoin? Is anything about that?
Yes. So I typically don't mention Filecoin since it's a unique, more storage-based network rather than like generalized smart contract. But we also do have support for Filecoin. I believe we launched that at the end of 2021. Sorry, end of 2020, and that's been great to see. The adoption there has been, I think, a little bit slower because if you're utilizing the Filecoin network, it's more for long-term storage rather than for like immediate data retrieval. But it's something that we've always felt like with our relationship with IPFS and our great partnership with Protocol Labs, that it's something that will evolve and we will eventually transition to being able to utilize Filecoin for more immediate storage and retrieval. Right now, we utilize IPFS and we promote IPFS as the way that people can, for example, store and retrieve their NFTs, and that hopefully in the near future, we'll be able to also utilize the Filecoin network in a much more distributed or decentralized way.
Great. Thank you, EG. One more question here. This is coming in from Jordan. Do you support Velas? I don't know if I'm saying it right. It's Solana's fork with EVM.
Yes, so that's the one that I think I had heard of. We haven't had any discussions internally about when we would support that. That's kind of the thing that I was saying. If developers are asking for it, we'll do it. There's nothing that we're like philosophically opposed to. That's not part of our ethos. That's never the way that we've been. The thing that really pushed us over the edge and said like, okay, we have to do this is just the sheer amount of developers that were asking for Polygon. It was pretty overwhelming. Like there wasn't a day that was going by where we weren't seeing people asking for it. And so we'll put Jordan on the list as one of the people asking for Solana support. And if more people are asking for it, our product folks are going to listen.
And that would be to my question, EG, how can people, is there a place that people can go, our community, to request, like feature requests or things like that? What's the best place for them to do that?
Yep. If you go to our Infura.io website, there's a community link there, or just go to community.infura.io. It's our Discuss forum. You can ask questions. You can put in feature requests. I'm in there. I take a look at the questions that people are asking, and you can even pose a question to our product folks, and they'd be happy to brainstorm anything with you.
Awesome, thank you. And last one, and we're going to jump to Ankit, is they're wondering, this has come from Musab, is saying like, do you know time frame wise when Infura would be including BSC, Solana, and other blockchain for developers? Is it, to your point, based on demand, or do you have a time frame on that?
So demand determines when we add it in our pipeline of things that we can add. We're just like other people in this space struggling to scale the team, because once we add a network, it's a huge operational commitment. We're not the type to say we're going to add something and then we're going to remove it 3 months from now, because if you're building your application on top of Infura, you want to know that it's going to be there for years, and it's not something that will just get sunset in 6 months. We never wanted to be an API provider that did that. And so we need to make sure that the engineering team and the operations and support teams behind that can support the additional network. When we add a network, it's different than traditional like software infrastructure, because you're not just running the software, you now become part of the community. Like we're very much a part of the Polygon community, the other layer 2 communities. We track the governance decisions that are happening. Different forks and network upgrades affect us significantly. And it's something that we won't do it lightly. We take a look at it from like a technical perspective, like how intense will this be for us to be able to support this network? What are the operational requirements? And then are we prepared to do that and commit to that? But so no specific timelines on those, but definitely Aurora is not the only network we'll be adding in 2022.
Awesome. Thank you, EG.
Sure,
and we'll answer
everyone.
any other questions at the end. But we're going to hand the microphone over to Ankit. Ankit, we're going to switch share so you can share your screen. So let me go ahead and close that out. And then go ahead and hello there. Yeah. And then introduce yourself, but go ahead and try and share your screen so we can get that going first.
All right. I think you can see my slides.
Great.
Here.
Yeah, it looks good.
All right, we should be good to go. So hi, folks. I'm Ankit. Right now, I'm a blockchain engineer at Polygon. And I, along with a couple of other people, built a feature called gas swap, right? So basically what I kind of want to tell you guys is how we kind of built it and why we needed to do it. So essentially, the entire idea is just essentially leveraging meta transactions to kind of improve user experience. So in case some of you are new to Polygon, it's essentially an EVM compatible blockchain. It was founded in 2017, and essentially our mission from the get-go has been to essentially scale Ethereum. You might have heard now we have more chains that are going to be launched in a couple of months or years. So Hermes, Maiden, Zero, all of these chains, which are ZK rollups, will be coming soon. So like, for example, we have 3,000, more than 3,000 apps. We have around 7 million transactions happening daily, 60 million unique user addresses, and a 12 billion plus market cap. And we have a 2-second block time, which actually makes gaming a very lucrative decision on our blockchain. And so essentially, if you want an EVM friendly experience and a fast blockchain, which is cheap and works for everyone, that's essentially what Polygon is for. Now let's get back to what I actually want to talk to all of you guys about, which is essentially the gas swap feature. And I think the first question that we should have is like, why did we need this feature, right? Why was this feature built in the first place? So essentially what we were doing before is that every new user who had essentially no Matic could receive certain tokens, a certain amount of tokens, airdrop to their wallet automatically if they had never had any balance before. And after a certain point of time, you have to realize that for a token that has limited supply, so to say, since it's a fixed supply token, and there's some infrastructural costs as well, you kind of have to start thinking about how does this scale to the next billion users, right? Because that's essentially our goal, a blockchain that everyone can use. And that is when we kind of came up with gas swap, which uses something called meta transactions to essentially something that already exists. And we kind of put it into a ready-made solution where people can actually get Matic tokens for assets they already have without actually having to pay for it with actual gas, right? So the issue is that if you want to use the blockchain for the first time, you will not have ETH or you won't have Matic, right? And so that kind of results in a bad UX where people who kind of want to use it can't use it. And that also means that if you're a first-time user and you kind of want to use the network, and then let's say you have some USDC or maybe you have some WETH, and you're just angry, like you want to use it, but you can't, right? So like certain other chains have different solutions for this. The most common is the airdrop approach that we had previously. Then you could also do a strategy such as airdrop users that active with other chains, sort of a vampire attack, which I guess no one has tried, but it's feasible. And I guess another solution, which I think Phantom does, is you can run a faucet that essentially drips gas on some predefined metrics that you kind of define. And so essentially, we kind of just changed this entirely with gas swap, which essentially allows you to bridge your other assets, and then you can actually get Matic tokens, any amount of Matic tokens as a way of using the network and using those assets that you already have, right? So this flowchart kind of just explains how it works, and I'll just walk you through it. This is kind of going to be kind of technical. Sorry about it. I didn't probably think about it that much, but so essentially what we have is a 0x API that kind of serves as the data. So let's say we can have the buy token, we have the sell token, we have a buy amount, and we have the slippage. And essentially from the API, we get the call data for the 0x proxy. And then we have our own gas swap contract, where we can essentially pass in the 0x approval address and any arbitrary bytes that we want. And this is the first step to kind of formulating the meta transaction, where we encode this fill quote function data or whatever we want to call the 0x proxy with as a EIP 712 meta transaction. So we add things like the from data, the contract nonce, and the chain ID as a way to ensure that these transactions or meta transactions can't be replayed. So that kind of ensures security as well. And so like if you ever use the feature, you're going to notice that you kind of have to sign certain payloads, so to say, which is using the ETH sign typed data v4 RPC call, which is essentially what we are doing is we're providing the meta transaction data to the MetaMask wallet in the form of a structured data type, which is what EIP 712 is all about. And so after you sign the data, you essentially have the VRS of the signature, then you have the function data, and then we can call the main function, which is the execute meta transaction. And this is our function in the contract that essentially checks that the signature and the function data you're providing is actually accurate, and it works exactly as it's supposed to be. So we check that the signature is valid, we check that it does not call itself, and we then increase the contract nonce to ensure that you cannot replay the meta transaction. And ultimately what happens is whatever data that you supplied, so in this for encode function data step, it calls the contract with that data. So it's like a normal transaction happening at that point of time, except obviously it's happening in the execute meta transaction. And then we return the control to the fill quote function, which then calls the 0x proxy with the call data that we got from the API. So due to the way that the Matic token is essentially like a balance, so it's like an EVM compatible or like an EVM balance, so to say. The way we need to kind of deal with it is different from typical ERC20 tokens. So we also perform some additional validation, such as we check if the output token is Matic. And then if we check that the return amount is always more than the expected amount. So if you remember that we took some slippage into account, right? And that is to ensure that it's like, let's say that you get arbed, the entire transaction reverts and you kind of don't have a loss. And so now like going back to the 0x proxy, you have this another function called the transform ERC20. This is where the 0x logic of it happens, where it's essentially a liquidity aggregator, right? So what we do is we provide a series of transformations to the tokens. So it's essentially a way of telling the contract that your DAI will now become ETH, your ETH will now become Matic, or so to say, like whatever the order is. It's a way of forming the order, so to say. And then the swap gets performed in the contract context, which is the gas swap that's all contract. And whatever tokens that we get from the 0x proxy, we just give it all to the user. And that's our automagical but slightly complicated way of making gas swap work. Now let's talk a bit about what meta transactions are in the first place and why we need to use it. So just to talk about the EIP 712 standards, essentially it's an Ethereum type structured data hashing and signing. So typically what the standard kind of defines is a way for you to kind of sign data and have it parsed by contracts in a way that it can perform actions in the user context. So now some things are part of the standard and some things aren't. Like, for example, we have added something like a contract nonce. This doesn't necessarily need to be part of the standard, and it isn't. But let's say that your encode data or the transaction data includes it. It is possible. Like, for example, like you can see, in our case, we have the transaction data as the from address, the contract nonce, and the data that we want to be called in the contract context. In a different contract, maybe they do not want the from address, maybe they only want the to address, or maybe they don't want the nonce, maybe they want the expiry time. And this is what kind of allows like a dynamic sort of usage, that you can have different forms and different ways of making meta transactions work, and not just one thing. So EIP 712 is more about structured data hashing and signing than actual meta transactions. So what EIP 712 is actually like the foundational base on which we kind of make it work. Now going back to what EIP 712 has, it's so like typically since it's a typed message, we need to add a message like the Ethereum signed message that prevents collision with other signed data like a normal transaction that you'd sign it, right? And you can also add type hashes like that essentially prevent like two different functions from being called. And finally, what we have to kind of separate two different things, two different dApps is what we're calling a domain separator. And this is essentially what happens is that let's assume a case where your function type hash is the same. You have added the typed message like this, and you have the transaction data that is also the same. What if a dApp could kind of copy other dApps data, and that is essentially why you need a domain separator, where let's say you have the Aave app and you have another app which is the Uniswap app, and essentially since the fact is that in the UI you're going to see them as different dApps or domain separators being shown in the UI, so you cannot spoof other domain messages, and that kind of prevents signature collisions as well, since that serves as a distinction between two similar transactions. So this is the kind of the code aspect of how we make EIP 712 work. So if you remember, if you go back to the execute meta transaction function call, you typically have something like the user address, you have the function signature, and then you have SIGR, SIGS, and SIGV, right? What we do first is to kind of transform it into a struct, like a meta transaction. So if you remember from before, we have the nonce, we have the from, and then we have the function signature. Then we encode it with the data that we just saw, and then we get the meta transaction type hash. And this is the meta transaction type hash that I was talking about. This kind of prevents with the function signature collision, so to say, since the function name will typically be different in other cases, right? And then this hash is what we use to kind of, if you remember, the user also provides us the RS and V, and then using the VRNS and using the hash meta transaction, we can use EC recover and solidity to get the decoded address of a particular user. So basically by getting the actual signature and by getting the VRS, we can decode the address using ECDSA. And then we also have the user address from before, which is provided to the function. And then we just perform a simple check that if the address does match, then we accept that meta transaction. And if the address doesn't match, then we reject it. And that is essentially how we are using it in our contract, so to say. Truth be told, the IP 712 has a lot of depth to it that is more than what we are kind of utilizing here. But that's because our usage is kind of meant to be different, since it's more about enabling meta transactions and less about structured signing. And this is where we kind of come to the last part of what I want to talk about today, which is talking about transactionary layers and why we use them. So now a very good question is, why would you want to use layers, right? And I guess the most basic reason is that you don't need to do it yourself. The drawback that comes from doing these transactions yourself is that you're going to have the added cost of storing all those private keys safely. And then you're going to have the added cost of managing nonces or managing those transactions, which is kind of problematic. And if you kind of want it to scale, it gets annoying really quick. And that is from my own experience as well. And also another thing is that most blockchains now, right, which have any amount of usage, let's say, let it be Ethereum or Polygon, they all have dynamic gas fees that kind of change from time to time and depending on network congestion. And there is no fixed way to determine what is the correct gas price, right? So this means that if you're a dApp or if you are a service provider who kind of wants to use these transactions and you want to do it yourself, these transactions might get rejected. If the gas is too low, they might get dropped. They might get stuck as pending. And that is just really bad for UX. You just don't want that. And that is where kind of transactionary layers come in, where essentially you have Biconomy or have Infura ITX who are really good at doing this sort of stuff, where when you want to use meta transactions, they'll just relay it for you as long as you have the gas tank up to date, and that's pretty much it. And the reason this works now is because now we have the infrastructure to kind of automatically price transactions as needed. So like in the case of even if the gas fees are kind of very dynamic, they still have ways to kind of get around it. And let's say that transaction has not been mined for a fixed amount of time, then they will also perform speed ups as needed to ensure that it definitely gets mined at a certain point of time. And this is what kind of results in a very good UX. Because ideally we do not want a case where transactions are repeated, or any case where transactions kind of are pending for a long period of time, because the throughput that we want is very high, right? So this is how a typical flow with Infura ITX works. It's pretty simple. So typically what we have is we have a backend that kind of adds Matic to the Infura ITX gas tank. And from before we have the user signed MetaTX, right? We kind of just abstracted away that flow before as just an execute meta transaction call. But there's this added step that happens here where we kind of send their MetaTX to Infura ITX. So Infura ITX has their own kind of RPC calls. One of them is called relay send transaction. So essentially what happens is we use the Infura RPC to kind of send a request from our backend to the ITX contract, it's like a meta transaction data. So we just provide whatever the data that we had. So what we are giving them will be like the to address, which will be the gas swap contract, the data which will be the user signed meta transaction, and then the gas that we want Infura to forward. And then we also provide a mode like fast or slow. And like we are just picking fast here because we want it to be fast. And essentially this goes as a signed transaction. And this is what we kind of send to the Infura ITX. And eventually what happens is that transaction that we have actually goes from the Infura ITX relayer to our gas swap sol, which executes that function call, which is essentially an execute meta transaction call using the user signed meta transaction bytes that we had from before with the gas price that Infura ITX has kind of calculated, so to say. And assuming that it doesn't get mined, it's just going to retry that until it gets mined. And I think the fast mode has a 1 minute and 30 seconds kind of delay. So it just picks up the gas price if required. And also in that step, what happens is that the Matic gets deducted in from our gas tank. And that's pretty much how relayers work. To be honest, like this is just one example of relayer. Different relayers have different ways of doing it. But since we're kind of planning on using Infura ITX, this is a flow using that. And that's pretty much it. Thanks a lot for listening. Thanks a lot for understanding how gas swap works, folks. If you want, you can give us a follow at 0x Polygon and myself at QEDK_, and that's pretty much it. Thanks a ton.
Thank you so much, Ankit. We do have a couple questions. There's a question about, and thank you, EG, for answering some questions. Check that out, everybody. There are some answers on there that we're helping you with if we don't get to it up here. A question about, will ETH2 be more powerful than Polygon? That's coming in from Yogenth. Am I saying that right? Does that make sense?
To be more powerful than Polygon.
Yes, it's a kind of vague
question. It's a common question that we get, but honestly, I'm not sure of how to answer that, because it's like, as we've kind of established many times before, is that we don't believe ourselves to be adversarial to Ethereum. We believe that we are firmly centered on Ethereum. And also the fact is that we have rollups, ZK rollups and optimistic rollups in the works that will eventually use the security of Ethereum. So if anything, I believe that it'll be more of a collaboration than who has more power, I guess, yeah.
Right, that makes sense. And a question coming in from Gustavo is, obviously scalability is vital for the blockchain's future. Do you think that there's going to be L3 solutions basically for developers, or are there already solutions in mind to accommodate this scaling need? Also, what about data storage?
Yeah. That is a very good question. So essentially, we are seeing this come into more solutions come into the space. For example, that's the exact reason we kind of came up with Polygon Avail, which is a DA solution. And I guess the ideal world would be where we have ZK rollups and then you have DA solutions available, which are in parallel. But yeah, in an ideal world, yes. we will have L3s.
Nice. All right. Well, we're going to hop over. Thank you so much, Ankit. And like he said, you can reach him on the contact him on Twitter and also the resources he mentioned. And by the way, after this call, hello, Gonzalo, you are next for sure. We will be sending the replay link is actually the exact same link you're on right now, but we'll be sending you an email with that replay link as well as the slides in today's call and your special POAP code to claim your special Infura badge. So without further ado, let's go ahead and Gonzalo, did you want me to pull up the slides or did you want to drive?
I'm okay driving, I think.
Okay,
Let's
great.
try it out.
All right, so go ahead and grab those.
Let's try it out.
And thank you again, everybody. Questions that you put in the queue, you can also upvote them if you're interested in saying, hey, oh, definitely we want this answered. So please do that. All right, great. You're looking good. You're on, Gonzalo.
I'm on. Hey, guys. Thank you, Shay. And thank you for inviting me. I'm loving it here. It's my last call before Christmas. I'm already feeling it in the air. So for those of you that do not know me yet, I'm Gonzalo. I'm one of the co-founders of the Diligence team. And the Diligence team, I'll give you a brief introduction to the Diligence team, which will help me explain the thing that I will be presenting to you today. The Diligence team has existed for the past almost 5 years. And I believe we were one of the first crypto native security companies to pop up, probably along with the Open Zeppelin. And we've audited pretty much everything since the Big Bang, since the existence of Ethereum. Those logos that you see there is just like a small collection of all the big names that we've audited over the years. And Diligence itself came to be purely as a service provider, right? So we would do code reviews and penetration tests and so on and so forth. But 1.5, 2 years into our operations, we decided that we really wanted to automate ourselves out of the picture. And so this meant that we started creating products in-house. Those products are, until today, mostly focused on two things: either helping developers writing more secure code or automated vulnerability finding, right? So finding those vulnerabilities without any human interaction. Our first product, or our first suite of products, which came to be, which had its existence as a SaaS product, was Methx. Methx started as purely as a single tool created by Bernard Mueller called Mithro, which is a dynamic analysis tool, right? So it had its own symbolic execution engine. But soon, right after Bernard joined the team, Mithro got a life of its own, and it expanded into a suite of tools, and not only that dynamic analysis tool. So to join Mithro came Maru, the static analyzer, and Harvey, the fuzzer. So Methx has existed for quite a while now. It's a really good product. You should use it, but it's also a really opinionated product, right? And it looks for vulnerabilities that are maintained by us in something that we call the SWC registry. I'm sure we'll be able to send you all those links afterwards. And while I'm demoing, I'll also might be able to show you these things. But Methx, the point being that Methx is a very opinionated tool, right? And it looks for specific things, but it's non-customizable. You know, it checks for these well-known and previously found in other code bases classes of vulnerabilities. What we thought is that this was not enough, right? You all have very different business logics. dApps vary wildly, right? Even though we all use the same set of standards, like the ERC20 one, but the business logic of the apps vary wildly. And that's what drove us to create this thing that I'm going to talk to you today, which is the Diligence Fuzzing product. So during the last year, or right now, like a year and a half, maybe, we had been trialing in-house this runtime verification language that we created called Scribble. Well, it wasn't called that back then, but we had we were trying to come up with an expressive language that had a familiar syntax, with which you could express your business logic and have our tools check for that. And I'm just realizing now that I had like a slide prepared for demo time, but I might as well just show you all those things in real time. We're still getting this. Perfect. So we came up with Scribble, and Scribble is a pretty powerful thing. So again, the syntax is very familiar to whoever develops in Solidity, and it's very much akin to a specification language. The main difference being that with the specification language, for those of you that are familiar with the term in the audience, the specification language is like, okay, actually need you to specify the entire contract, right? They are part of this group of techniques called formal methods, right? More specifically, people call them formal verification tools, because whatever you write in there, whatever the specification contains, will be mathematically proven, right? Scribble differs a little bit from those tools, because it doesn't need to fully specify the contract. You can just like write annotations, and we can look at some examples here. So as you see, you have them as doc strings, as NatSpec comments. And so this is just an identifier, but the syntax should be pretty familiar to all the Solidity developers, with the exception of a few keywords that are not present in Solidity, that are meant to augment the power of Scribble. Scribble itself is a transpiler. So as you see here, you have a Solidity contract that is annotated. Annotated meaning you have created those annotations on top of functions or invariants on top of contracts. Scribble transpiles it to another Solidity contract that actually is able to check for those invariants or for other different annotations, right? Back to our presentation. And knowing this, we have actually extracted from the Methex family of tools just the fuzzer, and gave it different robes, and actually enabled much powerful campaigns. And that's exactly what we call diligence fuzzing. Diligence fuzzing is Harvey, the fuzzer, in its own infrastructure, and we allow you to run the fuzzing campaigns, as we call it, for a customized amount of time, right? Another thing that is good it's just like good if you're starting to develop your own product right now, is this scale right here is actually a representation of where each thing fits into the timeline, into the development life cycle of your product, right? You see there, like right after you start the ideation and planning, you should also start annotating your code, right? So this should be baked into the development process. We also believe one thing in our team is that Scribble annotations will actually enable your development team to develop faster. The reason for this is that the developers will be able to encode their assumptions as Scribble annotations, and whenever anyone else from the team needs to pick up a part of the code base, I don't know if you can hear the construction work. I apologize if it's loud. But it's so it actually allows the assumptions of one developer that is developing a piece of code to be in the code already. And so when someone else comes to work on that same part of the code base, they will know, oh, so that's what John meant with this line of code. Now I also have his assumptions in my head. Fuzzing, this is a quick prime on how fuzzing works. So fuzzers are basically tools that throw random inputs at a certain algorithm, and try to break it, right? So some open source fuzzers just try to create segmentation faults or try to halt program execution somehow. In this case, Harvey, or Diligence Fuzzing as a product, actually looks for assertions in Solidity. That's our way. So we don't mess with reverts, but assertions have become kind of a standard for more formally oriented tools to check for faults in your program. So like as a best practice, you should be using reverts in your code, because it actually reverts back the extraneous amount of gas to the user if it is in use, right? If the execution is halted, and asserts have been kept by the Solidity team in the language specifically for this purpose. And let's go back and let me show you how the platform is looking. So I'm not going to run the demo live. I actually ran the campaign before, because I know the Murphy's laws, and I know that this should somehow break. But what we have here is a campaign for one of our Scribble exercises. We'll be able to actually give you all these links afterwards, so you can check it on your own time. And in this specific case, the campaign that we just ran, it was ran on this annotated ERC20 contract. So this is an ERC20 contract, a normal one. And for those of you, maybe we can do a question review. If there's any security aficionados in the audience, if you guys want to take a stab, I'll give you 30 seconds to tell me what's wrong with this transfer function, or any developers. Anyone want to take a stab at it? Looks fairly innocuous, right? But the problem being it probably requires more time and more attentive eye than what we have time for it today. But the problem here lies on the fact that we actually do not account for a good rebalancing of balances if someone sends money to themselves, right? And so basically, the process here would be, if you're a developer writing Scribble annotations, the process would be for you to start adding properties that make sense, like we say here. So, for example, one of them would be, if the transfer function succeeds, then the recipient had sufficient balance at start, right? The sender has to have sufficient balance. A good one, makes sense. Then if the transfer succeeds, the sender will have the value subtracted from their balance, right? Another thing that makes sense, you want to make sure that they actually lose the money if they're sending it elsewhere. If the transfer succeeds, then the receiver should also have the value added to their balance. Another one that makes sense. And this is the one that actually catches the problem with this piece of code. If the transfer succeeds, then the sum of the balances between the sender and the receiver should stay the same, right? It's zero sum. Nobody should be getting more tokens just by doing a plain transfer. We don't want to mess with the total supply. And so that these conditions are written here as you see them. Those were just like 4 examples of some of the things that were written in this ERC20 specification. And after we ran it, so this campaign was fairly small, right? The code base is also fairly small. So typically you would leave these campaigns running for 24 hours with I don't know, like upwards of 4 or 8 CPU cores. So it's a lot of CPU hours because your code bases tend to be really big, right? Like the products out there tend to have like really big code bases. And we can see the quick statistics. Like we get a 72% of code coverage. The number of instructions, we can also check them here. And then we see the violation, right? Again, since this was a small code base, the violation is we get to the violation fairly quick. But we can see that what lines of code were covered, and we can see where the assertion violation was triggered, right? This is obviously after we use Scribble and we run the Scribble commands. But yeah, basically we can see that it was triggered with the message for colon. Well, clearly this was a different message than the annotations that we have here. But this is basically it. Then we also have live updates. If the campaigns are running for a really long time, we'll be able to actually give you updates in real time, so you can react to things if, for example, the code is already deployed on mainnet. And we have a bunch of other cool depends on your definition of cool, but cool metrics. So how many branches were covered, how many paths were covered, the total test cases, because fuzzing is basically just an automated way to create a bunch of unit tests, right? And all of those good things also in graph format for the graph aficionados. And that's pretty much it. If we're going to distribute the slides, you'll be able to access all of these good links through the slide. If not, again, I'm sure we'll be able to distribute this somehow. And as EG said, I'm more than happy to answer all your messages on Twitter or hit me up through email. Thank you.
Awesome. Thank you so much, Gonzalo. This is amazing. And we appreciate it. I know we ran out of time, but this could be something maybe we could kind of, like you said, continue the conversation on our Discord channel, or hit you up on Twitter. And if anybody is interested in deep diving a little bit more on what he showed, definitely do that. One quick question before we kind of wrap up. There was a question from Brian about, can you speak to the 51% attack issue?
Sorry. So
There
that's
you go.
Hey, that's a very more of like a generic, like not so much like app layer attack, right? Like the type of attacks that you see today, like on Decentraland, but more of like a protocol layer attack, and that's basically all due to hash rate, right? At least when you're using like proof of work chains like Ethereum is. Not so much after the merge, right? Like the finality guarantees that ETH2 gives us will actually mitigate at least the designation of a 51% attack. It'll be somewhat of a different percentage, but yeah, as long as you have decent hash rate, the price of actually performing a 51% attack is way too high. At least when we're talking about hash rates like Bitcoin or Ethereum in other well-known chains.
Awesome. Yeah, thank you. And can you move it to the last slide there, or you close the slides? That's okay. I didn't know if there was call to actions on the last slide there, Gonzalo. Did we lose him? Oops. We lost Gonzalo. So let's bring him back up.
Gonzalo did an Irish goodbye.
So May, did you want to kind of do a wrap up with any remaining things? And like she's been putting on the chat there, this will be available for you guys as a replay at the exact same link. Like I mentioned, you're going to get an email follow up to this call to say thank you for attending and all the goodies that we're going to send you, links to slides, links to replay this, as well as get your claim code for the call. And go ahead, May, if you'd like to leave with any takeaways here. Let's see if we can get Gonzalo back.
Yeah, thank you so much for being here. Everybody seems to be from every corner of the world, so we're really grateful for you. If this is not, your normal time zone, really grateful for that. So last but not least, definitely sign up for a free account at Infura. Start building today. We're grateful to all 350,000 and growing developers that are building on Infura. And yeah, definitely enjoy the holidays. And some people had some questions about POAPs. We're going to email you the lucky winner for the POAP. And yeah, we'll see you in the new year. And we have already a very exciting lineup in January. So definitely stay tuned. Follow us on Twitter.
And thank you all, Ankit, EG, Gonzalo, and May. Thank you so much. And thank you all for attending. And we hope to see you in January. Happy New Year and have a great holiday.
Happy New Year, guys.
Thanks, everybody.